What's going on, guys? Welcome to NetSec Explain. In this video, I'm going to show you how to perform command injection for web app security testing. Command injection is a little different from code injection, like the SQLi and cross-site scripting videos we went through earlier. Instead of trying to write or manipulate some code to be ran by the web app, we're just trying to extend the way the web app uses operating system level commands. There are several types of switches that operating systems can use to run multiple commands on the same line. If the web app doesn't filter those switches, then a user can abuse this to run other OS level commands with the same permissions as the user account running the web server. For example, if we had a web app that would cat or read a user input text file, it would be as simple as saying cat user input. Now, what if the user types in my text file followed by a pipe or an and? Then they could run a second command along with it. So it could wind up being cat my text file and list directory. From there, they could craft a command that would allow them to execute a backdoor or perform other post-exploitation attacks. So let's see what this looks like. We're going to be using Damn Vulnerable Web App for this demonstration, and before we get started, we're going to want to set the DVWA security setting to low. This will give us the simplest environment to work with. The first thing you want to do with any new application you're trying to break is to get an idea of what the underlying source code looks like. Here, we have the ability to ping any IP address that we enter, so I'm going to enter in quad 8, which is Google's DNS server. And when I hit enter, we can see it returns connection results for quad 8. Pretty straightforward. Looking at the output, it seems oddly familiar. It looks like a system-level ping command. Let's open up a terminal and try our own ping to see what we get. Sure enough, the output of these two look exactly the same. Now, real-world applications are almost never this easy to identify, so you're going to need to do a bit of playing around to see if it's using OS-level commands. In the meantime, let's take this example and try to rebuild this part of the web app in Sublime. We have our user input, which is the IP address quad 8. Then from what we can tell, it's using the system command ping with our input. In the end, it returns the system command ping quad 8 and displays the output. So what if we wanted to run our own second command here? In a terminal, you can type ping quad 8 and dir to return both the results of the ping command and list the directory. Working backwards, the only thing that needs to change for us to get this command is to add and dir to our input. Let's try this out. This is our payload, so let's copy or type it into the form. Hit enter, and we can see the results of the ping command just like before. But if we scroll down, we see something new, the listed working directory. Awesome. Now, here's why the video is so short. This is about all there is to command injection. Normally I'd tell you to do post-exploitation tasks like uploading a backdoor, but this is a system-level backdoor. There's not much more we need to do here. But just in case, what if we have a situation where it's much harder to tell if we're using system commands? For instance, it only returns a yes or a no as output. Well, we can use the sleep or timeout command to determine if we have system-level injection. From there, we could upload a PHP backdoor and use that to gain better feedback. Using and echo, we can craft a system command that saves our PHP backdoor by redirecting output to a file. The backdoor itself is a simple PHP script that uses the pass-through function to execute and show us any system-level command that we give it using this CMD parameter. Copy it and throw it into the browser. Since we didn't give it an IP address, we see this usage information for ping, but we don't need to worry about that anymore. Go to bd.php and type in the command dir to list the directory. And just like that, we were able to exploit a command injection to upload a PHP backdoor for better feedback and persistence. So how do we prevent something like this? Well, the most basic advice would be to whitelist and validate user input. You should already start to notice this as a theme. Better advice would be to limit application permissions and use a language-specific API instead of the system or exec class of functions. Command injections run with the same level of permissions as the exploited application. If you strictly limit what your application has access to, then an attacker won't be able to get much further than what they already have. Finally, using a language-specific API, like a PHP version of ping, will eliminate all command injection vulnerabilities completely. that's all I have for you guys today. For more information, check out the links in the description below, and don't forget to like and subscribe to see more videos like this. I'll see you next time.